السلام عليكم. محاضرة 11 نكمل وياكم الكيميكال كنترول of respiration. ناخذ effect of CO2 والهيدروجين والأكسجين on the peripheral chemoreceptors وناخذ patterns of breathing. Peripheral chemoreceptor system for control of respiratory activity, role of oxygen in the respiratory control. نحكي بالمحاضرة السابقة قلنا إنه ال central effect mainly هو oxygen mainly هو CO2 والهيدروجين اللي هو يرفع الريسبيراتوري سنتر. بالنسبة للبروبر كيموريسبتورز المؤثر الأساسي هو الأكسجين. In addition to control of respiratory activity by the respiratory center itself, still another mechanism is available for controlling respiration. This is the proper chemoreceptor system, as shown in the figure 41.4. Special nervous chemical receptors called chemoreceptors are located in several areas outside the brain. هذا اللي موجود وين؟ البريفرال كيموريسبتورز مثل الكاروتيد بودي موجودة وين؟ بالايورتيك بودي. سيرد سيجنالز عن طريق الفيجاس والبلازوفارنجيال إلى الميدل respiratory center. They are especially important for detecting changes in the oxygen in the blood, although they also respond to a lesser extent to changes in the carbon dioxide and hydrogen ion concentrations. The chemoreceptors transmit nervous signals to the respiratory center in the brain to help regulate respiratory activity. Most of the chemoreceptors are in the carotid bodies, however, a few are also found in the aortic bodies, shown in the lower part of the figure 41.4, and a very few are located elsewhere in association with other arteries of the thoracic and abdominal regions. The carotid bodies are located bilaterally in the bifurcations of the common carotid arteries. Their afferent nerve fiber pass through the hearing nerves to the glossopharyngeal nerves and then to the dorsal respiratory area of the middle limb. The aortic bodies are located along the arch of aorta. Their afferent fibers pass through the vagi, also to the dorsal respiratory area. Each of the chemoreceptor bodies receives its own special blood supply through a minute artery directly from the adjacent arterial tract. Further, the blood flow through these bodies is extreme, 20 times weight of the body themselves each minute. Therefore, the percentage of oxygen removed from the flowing blood is virtually zero. This means that the chemoreceptors are exposed at all times to arterial blood, not venous blood, and their PO2 are arterial PO2. Decreased arterial oxygen stimulates the chemoreceptors. When the oxygen concentration in the arterial blood falls below normal, the chemoreceptors become strongly stimulated. This is demonstrated in figure 41.5, which shows the effect of different levels of arterial PO2 on the rate of nerve pulse transmission from the carotid body. Note that the impulse rate is particularly sensitive to changes in the arterial PO2 in the range of 60-30 mmHg, a range which hemoglobin saturation with oxygen decrease rapidly. نشوف هنا الارتيريال PO2 النورمال هو هذا تقريبا 195 ومقابله هو الكاروتيد بودي نيرف امبulses بير سكند، هذا هو النورمال. بعدين نشوف انه كل ما يقل اقل من النورمال كل ما يزيد الفايرنج بالكاروتيد بودي نيرف. القمه مالته هو او السترونج امبulse اللي هي من 60 الى 30 تصعد كلش هواية بها الكاروتيد نيرف فايبر امبulses، والعكس انه كل ما يزيد الساتوريشن كل ما تقل الفايرنج of the carotid body nerve. Increased carbon dioxide and hydrogen ion concentration stimulate the chemoreceptor. An increase in either carbon dioxide concentration or hydrogen ion concentration also excite the chemoreceptors. يعني مو بس الأكسجين، لكنه الفرق بينه وبين الأكسجين in this way indirectly increases respiratory activity. However, the direct effects of both these factors in the respiratory center itself are much more powerful than their effects mediated through the chemoreceptors. يعني تأثير السيوت والهيدروجين يكون أضعف مما هو على الريسبيراتوري سنتر. بالريسبيراتوري سنتر يكون أقوى مما هو بالبريفرال chemoreceptors. لكنه الفرق الآخر شنو؟ Yeah, there is one difference between the peripheral and central effects of carbon dioxide. The stimulation by way of the peripheral chemoreceptors occur as much as 5 times as rapidly as central stimulation. So, the peripheral chemoreceptors might be especially important in increasing the rapidity of response to carbon dioxide at the onset of exercise. إذا تأثير CO2 والهيدروجين هو أضعف بالبروتال تيومر سيتر ما هو مقارنة بمن بالسياتر respiratory center، لكنه صح هو أضعف، لكنه يكون الإفكت مالته يكون أسرع more rapid than the effect اللي هو central effect. Basic mechanism of stimulation of the tumor cells by oxygen deficiency. The exact mechanism by which low VO2 excites the nerve ending in the carotid and aortic bodies are still unknown. However, these bodies have a multiple highly characteristic glandular-like cells called glomus cells, which signal directly or indirectly with the nerve ending. Some investigators have suggested that these glomus cells might function as the chemoreceptors and then stimulate the nerve endings, but other studies suggest that the nerve endings themselves are directly sensitive to the low VO2. Effect of low arterial VO2 to stimulate alveolar ventilation when arterial carbon dioxide and hydrogen ion concentration remains normal. Figure 41.6 shows the effect of low arterial VO2 on the alveolar ventilation when the PCO2 and hydrogen ion concentration are kept constant at their normal levels. In other words, in this figure, only the ventilatory drive due to the effect of low oxygen on the chemoreceptor is active. نشوف هنا بالشكل هنا المتغير هو ال PO2 هذا، والثابت هو البي سي او 2 والهيدروجين. فنشوف هنا هذا هو الفيرال فنتيليشن، وهذا هو الارتيريال بي سي او 2 اللي هو يكون ثابت. النورمال ارتيريال بي او 2 اللي هو قلنا عليه تقريبا 195 هذا المكان هذا. كل ما يقل اقل من النورمال مفهوم نشوف الزياده بالفنتيليشن مع الثباتيه مال البي سي او 2. واضح؟ The figure shows almost no effect on ventilation as long as the arterial PO2 remains greater than 100, but the pressure lower than 100 ventilation approximately doubles when the arterial PO2 falls below 60 and then increases as much as 5-fold at very low PO2. Under this condition, low arterial PO2 obviously drives the ventilatory process quite strongly because the effect of hypoxia on ventilation is modest for PO2 greater than 60 to 80 millimeter mercury. The PCO2 and the hydrogen ion in response are made responsible for regulating ventilation in healthy humans at sea level. Regulation of respiration during exercise. In strenuous exercise, oxygen consumption and carbon dioxide formation can increase as much as 20-fold. Yet, as illustrated in figure 41.8, in the healthy athletes, alveolar ventilation ordinarily increases almost exactly in step with increased level of oxygen metabolism. The arterial PO2, BCO2 and pH remains almost exactly normal. نشوف هنا الأوتو consumptions وهنا الفنتيليشن. طبعا زيادة linear relation between the auto consumption and the ventilatory rate بالمودريت اكسرسايز والسبيد اكسرسايز حتى يبقون الأوتو والسي او 2 والبي اتش remain normal. Interrelation between chemical factors and nervous factors in the control of respiration during exercise. When a person exercises, direct nervous signals reasonably stimulate the respiratory center almost the proper amount to supply the extra oxygen required for exercise and to blow off extra carbon dioxide. Occasionally, however, the nervous respiratory control signals are either too strong or too weak. Then, chemical factors play a significant role in bringing about the final adjustment of respiration required to keep the oxygen, carbon dioxide, and hydrogen ion concentrations of the body fluids as nearly as normal as possible. This demonstrated in figure 41.9, which shows in the lower curve changes in the alveolar ventilation during 1 minute period of exercise and in the upper curve changes in the arterial PCO2. Note, at the onset of exercise, the alveolar ventilation increases almost instantaneously without an initial increase in the arterial PCO2. وهذا مهمة. في بداية الإكسرسايز الفنتيليشن يزداد هواية مع إنه ال PCO2 هو طبيعي. In fact, this increase in ventilation is usually great enough so that at its best it actually decreases arterial PCO2 below normal as shown in the figure. نشوف هذا الفيجر، هذا هو الوقت، هذا 0 قبل الاكسرسايز، وهاي 1 minute of exercise وهاي 2 minutes of exercise، وهذا alveolar ventilation، وهذا هو الارتيريال فيسيولوجي. نشوف انه في قبل الاكسرسايز الدقيقة 0 الفنتيليشن يصعد كلش بسرعة حتى قبل ما يكون زيادة بالبي سي او 2. هذا ايش راح يسوي؟ راح يسوي تدكريس بالبي سي او 2، يزيد الواش اوت حتى قبل ما يصير اكسرسايز، قبل بداية الاكسرسايز. وهي بداية الاكسرسايز تقدم الاكسرسايز في الدقيقة الأولى طبعا راح يرجع يصعد السي او 2 لأنه اكو مسلز فيها كونتراكشنز تزيد السي او 2 برودكشن. راح يرجع بأول دقيقة وين يوصل؟ إلى نورمال بي سي او 2 اللي هي 40. طبعا باستمرارية الاكسرسايز أيضا راح يصعد مرة ثانية، يستمر بالصعود، الفنتليشن أيضا راح يصعد وياها، بس بالنهاية راح ينزل، راح يرجع ينزل لأنه يزداد الواش اوت، يزداد الاسبيراتوري ريت، تنزل إلى الطبيعي. The presumed reason that ventilation works ahead of the building up of the carbon dioxide is that the brain provides an anticipatory stimulation of the respiration at the onset of exercise, causing extra alveolar ventilation even before it is necessary. However, after about 3 to 40 seconds, the amount of carbon dioxide released into the blood from the active muscles approximately matches the increased rate of ventilation, and the arterial PCO2 returns essentially to normal even as the exercise continues as shown toward the end of 1 minute period of exercise in the figure. Neurogenic control of ventilation during exercise may be partly a learned response. Many experiments suggest that the brain's ability to shift the ventilative response curve during exercise is at least partly a learned response. That is, with repeated periods of exercise, the brain becomes progressively more able to provide the proper signals required to keep the blood PCO2 at its normal level. Also, there is a reason to believe that even the cerebral cortex is involved in this learning because experiments that block only the cortex also block the learning response. Other factors that affect respiration, the voluntary control of respiration. Thus far, we have discussed the involuntary system for the control of respiration. However, we all know that for short periods of time, respiration can be controlled voluntarily, and that one can hyperventilate or hypoventilate to such an extent that serious derangement in PCO2, pH, and PO2 can occur in the blood. Effect of erythrin receptors in the airways. The epithelium of the trachea, bronchi, bronchiole is supplied with sensory nerve endings called erythrin receptors that are stimulated by many incidents. This causes coughing, sneezing, as discussed later. They have also caused bronchial constriction in such diseases as asthma and emphysema. Periodic breathing. An abnormality of respiration called periodic breathing occurs in a number of disease conditions. The person breathes deeply for a short interval and then breathes lightly or not at all for an additional interval, with the cycle repeating itself over and over. One type of periodic breathing, simultaneous breathing, is characterized by slowly waxing and waning. Respiration occurs about every 40 to 60 seconds as illustrated in the figure 4111. هذا النوع من البريذنج اللي هو channel stroke breathing يعتمد على rapid breathing. هاي onset of rapid breathing مثل تشوفوا بعدين يتوقف، بعدين يصير rapid، بعدين يتوقف أو يصير shallow. هنا ايش راح يصير؟ The basic mechanism of channel stroke breathing when a person over breathes, such blowing off too much carbon dioxide from the pulmonary blood while at the same time increase blood oxygen. It takes several seconds before the change pulmonary blood and can be transported to the brain and inhibit the excess ventilation. By this time, the person has already overventilated for extra few seconds. Therefore, when overventilated blood finally reaches the brain respiratory center, the center becomes depressed to an excessive amount. يعني لما نصير عندنا هذا الرابيد فنتيليشن راح يقل وياها منه البي سي او 2 ويزداد الاكسجين، بس على ما يوصل للبرين، على ما يصير بي سنسيتايزيشن، على ما يصير بي سنسوري في البرين يكون كلش نازل الهواء. فايش راح يصير؟ راح يصير عندنا cessation of ventilation، راح يتوقف. من يتوقف؟ راح يصير شارب انكريز بالبي سي او 2 وديكريز زيادة بالبي سي او 2 ونقصان بالاكسجين. وش راح يصير؟ راح يصير وياها stimulation of inspiration من جديد، يصير over stimulation of inspiration. Then the open cycle begins. That the carbon dioxide increase and oxygen decrease in the alveoli. Again, it takes a few seconds before the brain can respond to these new changes. When the brain does respond, the person breathes hard once again and cycle repeat. يعني هنا شنو المشكلة؟ المشكلة إنه يصير ديلي بالريسبونس بين التغيرات اللي تصير بالبلد والتغيرات اللي تصير وين؟ بالريسبيراتوري سنتر. يعني اكو ديلي وديلي بالريسبونس. يعني لما يوصل الريسبونس للبرين تكون الحالة غير شكل أو تختلف عن ما هي البلد عن ما هي اللي واصلة للريسبيراتوري سنتر. The basic cause of Chinese stroke breathing occur in everyone. ممكن يصير بأي شخص. However, under normal conditions, this mechanism is highly مسيطر عليه. That is, the fluids of the blood under respiratory center control areas have a large amount of dissolved and chemically bound carbon dioxide and oxygen. Therefore, normally the lungs cannot pull out enough extra carbon dioxide or depress the oxygen sufficiently in a few seconds to cause the next cycle of periodic breathing. But under two separate conditions, the damping factor can be overridden and Chinese stroke breathing does occur. أولاً, when a long delay occurs for transport of blood from the lungs to the brain, changes in carbon dioxide and oxygen in the alveoli can continue for many more seconds than usual. لما في تأخير بالبلد. Under these conditions, the storage capacities of the alveoli and the pulmonary blood for these gases are exceeded. Then, after a few more seconds, the periodic respiratory drive becomes extreme and challenge stroke breathing begins. This type of challenge stroke breathing often occurs in patients with severe cardiac failure because blood flow is slow, thus delaying the transport of the blood gases from the lungs to the brain. In fact, in patients with chronic heart failure, transient breathing can sometimes occur on and off for months. الحالة الثانية, the second cause of challenge stroke breathing is increase in negative feedback again in the respiratory control areas. This means that change in the blood carbon dioxide or oxygen cause a far greater change in ventilation than normal. For instance, instead of the normal 2 to 3-fold increase in ventilation that occurs when PCO2 rises 3 mm mercury, the same 3 mm mercury rise might increase ventilation 10 to 20-fold. The brain feedback tendency for periodic breathing is now strong enough because change stroke breathing without extra blood flow delay between the lungs and the brain. This type of stroke breathing occur mainly in patients with brain damage. The brain damage often turns off the respiratory drive entirely for a few seconds, then an intense increase in the blood carbon dioxide turns it back on the great force. يعني المشكلة وين؟ بالبرين. Chinese stroke breathing of this type is frequently prelude to death from the brain malfunction. Thank you for your listening.